Hello everyone and welcome to week 15 of Advanced Python and Production Development. My name is Mildred. In this lesson we are going to look at how to build our class project, and we're going to look at the different ways we can do the same thing. We're going to build the models. I'm going to do some as an example in the class, and I expect you to create the other forms. Okay, so we'll keep the meeting recorded. If you have any problems with your face being on YouTube, just keep your cameras. In week 14 we looked at the forms that we wanted to use for our application development. We are developing the maternity app, where we want to have a system that records all of the activities around pregnancies for a particular client. We want to have a maternity registration system. We want to have a pregnancy registration form on the system. We also want to have other forms that record antenatal encounters, postpartum, the birth, labor for postpartum, and also death if that occurs. So we already started building our directory structure. We have this source folder that we did in week 14, where we have roles as modules of this system. We have the administrator, the client, and the clinical. We say we want to build a role-based system, and we want to, as much as possible, use functional programming. Now, whatever we'll do here is not the best possible way, but it's going to guide you in the right direction, so that we're going to see how we do something and then we redo it in a better way. We already have our settings file that holds that extracts all of the information from our env file here. Our env holds all of the sensitive information. We say that when we push this to GitHub, we do not push the env file. It's going to be part of the git ignore, and when we do our final settings and we want to build the pipeline to production. We also use Poetry to manage our dependencies, and we have looked at that in week 13. We said also in week 14 that we have this init.py file, and the reason we just have this file here is one of the major reasons why we always have this init.py file, and you always see it in most large applications. It helps to treat the directory as a module, and when it comes to a lot of imports with those large applications, you begin to see the reason why we use this. And also we write initialization code here, so we'll try to write initialization code in this init.py file so that you can see that this file is going to have code that is automatically run and when that module is called. We want to change this. We have the models.py file, and here what we've been doing here is just try writing out all of the classes for our different tables. Now we want to do this properly. We don't want to have a models file. We want to have something that, for instance, each file will hold the creation of tables that relates to a particular form or a particular form group, so that we can, at the end of the day, be able to manage better instead of having all models on one file. So the first thing I want to do is to create an initialization file here, and I'll put new file, and this file will be init. Here I want to have a code that is common, and I will want to run every time we import modules or import files from this models folder. So I want to treat this as a package. This is the code I want to run that is common to everything. I'm going to copy this and I'll paste it here. So what we are doing here is, in SQLAlchemy we have two types of mapper configuration, and that is what we use to create table columns. We have two types of mapper configurations. We are using declarative mapping in this course. We have both declarative and imperative mapping. Imperative is kind of more used in older versions. Declarative is what we use in modern times. And in this declarative mapping, we construct a base class, and this and the superclass of this is the declarative base, so it inherits from the declarative base class. Now we create a base model, and whenever we have this declarative mapping process, it's now applied to all of the subclasses when the base class is subclassed. And in this place, we'll see that whenever we create a new class, we are going to be subclassing the base class, which will now apply all of this there. Now we have this declared attribute decorator that we use here, and this is just a class level method that it's usually invoked from an uninstantiated class, and I wanted to read about this decorator to see why we use it, and we just try to make things easier. And instead of rewriting codes or rewriting new methods, we have decorators that we can use that will help us to achieve what we want to achieve. Now we don't want anything in this file anymore, the models file, and so I'm going to be deleting this file. Now we have the initialization code here, and we know that in every model we are going to create, we will need this. We will need the base class and we will need the base model, and we're going to be inheriting or subclassing this in the new classes that we're going to create for our table. Now if we look at this, we don't need a lot of these imports. Whatever imports we don't need, you want to delete them. And so by the time we push to production, we want to look at standard that will remove all unused imports instead of taking imports that we do not use to production like this. So we have the init file. So we'll put this code here because when we create new files here, so let's create a new file called, let's say, user.py. So users.py. Now this, we want to write the model for the users table. Now what we said initially is that we want role-based access for the system, and by having role-based access, we want to say if a role of administrator is assigned to a person, we want the person to only see the functionalities of the administrator role. If the role of clients is assigned, they should only see the functionalities that we define for the clients. And if the role for clinical is assigned, we should only see the functionalities of the clinical person. So for us to achieve this, we already have the init file. We want to import the different data types that we need for the columns, like integer, string, date, time, because we want to have these different columns there. When we want to have a users table, we want to think about the different columns that the users table will have. So we want to have the email, password, the role, and then maybe the date created, something like that. So you decide what you want for your user table, but we'll create it like this. I know I'm going to be using enum because I want to select from predefined choices. So I'm going to import enum. I also want to import date, time, and integer and string, and let's say func. So I'll say from SQLAlchemy. So we'll import date, time. We import column. I don't need column. I need integer. I need string. And let's say I need, because I want for the date, I want it to be date, time now. So let me say I import func like this. And then from SQLAlchemy.orm, I want to import mapped column and mapped. So these are the different imports that I need. Also, let's go to the app file first before we continue. Now we have this app file, and this is the code we had previously from week 14. We want to change this code so that we can write maybe this whole configuration in a function. Now recall that we are trying to use functional programming to achieve what we need to do. So before we are able to use this app on the models file, let us restructure this app file so that we can have it like a function that we can run when we need to call anything or any function from that app file. So let's edit the app file. I want to change all of this app.secretkey, app.config. I want all of it to be like a function that I want to write. So I'll say from flags import flags, we need that. We also need settings here. I don't need this. I will take this out. I need create engine, and I will import other things later as we need them. For now, this is what I think I need. So the first thing we want to do is change this whole thing to a function. So let's say dev, and we want to say create app is the name of the function, like this. So what is the return type for this? Let's say it's going to have a return type of flags. And what do we want this function to do? We want to instantiate this flags, and we'll say, or create an object of the class flags is equal to flags name. So you recall this already. We also want to have the secret key here. App.secretkey is equal to settings.secretkey. So recall that when we, in week 13, we had created the settings file here that reads from the environment file. And in this settings file, we have created variables to hold all of the values that are set in the environment file. So we are now using the settings, and in the environment file, we defined the secret key already, and so we want it to read from that settings file. All right. So we say app.secretkey is equal to settings.secretkey. We also want to set the config now. Let's say the database URL. So we say app.config, and we have the URI to be MySQL plus PyMySQL, and we have settings.dbuser, settings.host, and dbname. So recall in week 13, we replaced all of these raw values with the values from the environment file. And then we also want to have the engine here. So say engine is equal to create engine app.config, the SQLAlchemy database URI, and echo is equal to true. Down here, we are going to write the statements that create tables. We're going to do that later. So once we get this done, the next thing we want to do is to return app. So we have all of this in a function. And what I'll do now is delete all of this. So what will happen next is I have to call this function before I can use this app, because now it's in a function. And so now I will say app is equal to create app. So I've created an object called app. So this is basically what we had before, but we changed this into a function so it can be manageable, and we can always import this function on other files. Does anybody have any question? Does everybody understand so far?
Yeah.
So we've converted it into a function, and we now have this. So we can now go back. We leave this if name equal to main, so we can always run this app file. So we'll go back to our users file now, and we'll try to import the app, because we have now made it a function and we want to import it for us to use it. So let's now say from app import, so we don't have to redefine it because we are importing it. Okay, in these models we'll have the initialization file that will have the base and the base model. We want to import that now, so we'll import that and say from models import base and base model like this. Now we want to create the user class. Now recall I imported enum here, and the reason I did that is because we know that we want to have 3 roles: administrator, client, and clinical. We want to have this predefined list of that the user must select one of these 3, and we don't want it to be a free field. So in the database, we want the database to store it based on these predefined values, and that's why I imported enum, and I'll show you how we use that, or how we create a class that has this enum or predefined list. We'll first of all create the user class, and this will create a table. So we'll say class user, which will inherit from the base and the base model, and then want to create the table name is users. So the name you want the table to have in the database is users. Here the database we want is the maternity records database. That's a database, that's the name we've given our database. Okay, so we have the table name to be, let's say user, or we can use users, whatever you want. Users plural is better because they are all there are many people there. So we're going to create our columns this way. Let's say the ID column, we are going to use mapped int, since we want it to be an integer, and we'll say this is equal to mapped column, and we want it to be integer primary key, and also want it to auto increment. So we'll say auto increment equal to true. We want to have email to be like their username, and this is going to be map string. Let's put nullable equal to false, unique equal to true, something like that. I'll just remove this for the sake of not having to provide default values or having errors. But when you are building your system and it's going to be holding real records, you have to enforce all of the constraints that the customer wants you to enforce. So we have password, and let's say the password is map string. We use the map column string 255. And let's now say the role. Now for this role, we want to do something. We want to create, let's say I'll create a class called role, and I'm going to inherit from enum.enum. And what I want this to do is to define admin user, or let's say admin client, and I want to let me put this in lowercase, and I want this to have the clinical role also. So I want to define this like this. And so here now, because I have these choices that I have created, so my role now is going to be equal to mapped role. So we'll just put it like this and mapped. So this makes it easy like this. So automatically we have created this predefined list, and that is what this is going to select from. And so let's say created at is going to be mapped. Let's make this a string, and then we'll say mapped datetime defunct. Now we can actually import datetime and use datetime here, or we can just do it like this. We can say map datetime, but let's leave it at map string like this. Avoid complications. Okay. So we have created the user table and the role table. We have defined columns ID, email, password, role, and created that. We want to now see if all is well and if this table is going to be created in the database. Before we do that, we want to go back to the app file, and we want to make sure that we add the code that will create that table here, the statement that will create the table. And before we can add that statement, we have to import from models. We want to import the create engine. No, from model I want to import user, sorry, because it's users that we created. in the models directory. So we want to import users, and here we want to write the statement now that will create this table. So we'll say users dot, the name of the class is user dot, let's just get the table name using this magic method, dot create, let's say engine, and then check first equal to true. Why I use check first equal to true, I don't want to have an error. If it exists, do not recreate. So it's just like saying in my SQL query, create table if not exist. So I put check first equal to true to make sure that it creates this table only if the table does not exist. Okay, so we have done this. Now it's time for us to test and see if this works. So let's go to our web page. We have this maternity records database. We have no table in the database. We want to see if the users table will be created when we run this. So if all is well, we expect to see a users table that has the ID, email, password, role, and created at columns. So no module name app is found here. From app, import app, we have app here. We return app is equal to create app. So why is it not found? So let's check. Okay, so this is one of the reasons I said that we need to have initialization file, init file in. So this will help us illustrate the purpose of this init file. We have it in the models directory. We want to have it, we have it in the source directory here, but we don't have anyone in the root directory. So let's do that and see if that solves the problem and we can find our package. So we have it now in the root, and hopefully this will make this a package and it can find what we are looking for. And so we won't have this cannot find app anymore. So you don't have to have a content in it. Just once it is there, it just makes this all a package, and then our imports will now be easier. Here we have from app, import app. We can't find that. Let's do that again and see. And sometimes we always need to restart, and I'll do that again, and let's see if we can find that. So we didn't use the app here yet. We might use it later, but I will remove the unused import for now, and then let's run the app file. So module enum has no attribute enum. Did you mean enum? Yes. So you can see all of the mistakes here. Enum. So we'll run again. No module named models here. So from models, import base model, and it's saying there's no module named models. So you see the problems that we are beginning to have with imports. We have a module called models, but it's not recognizing it. So let's clear this and we'll do that again. So most of the time you are going to have all of these problems, and then you're going to try to start retracing your step to find exactly where this problem is coming from and why we're having all of these problems. So we have the initialization init.py file here, and we have all of this here. We have the users file, and from models, import model and base model. It's telling us we don't have any module called model here. And why does it tell us that? We don't know yet, and we're going to find out shortly. So let's do it this way. We have the class role that we use to list predefined list for the column role that we need here. We also have the class user that inherits from the base and the base model class, and we're trying to run this for us to be able to create this in the database, and we're having import problems, and we are not finding some of our files or some of our imports. Now, sometimes this is based on the fact that the imports might be wrong, and sometimes it is based on the fact that we've not created the directory properly and this cannot be found. In this case, we have everything created as it should be, but we are not able to see why we're having the problem that we're having. So we're going to run this again and make sure or see if this will work. So we still have from models, import base and base model, module not found, no module named models. So let's go to run terminal, view command palette. We have the correct interpreter selected. So instead of saying from models import base and base model, let's just see if we can do import base. So this won't work. So from models, import model and base model. This is what we have here, and this is what it should be. So now we can't figure out why this is not importing why it's not finding the module. So now you'll see that you always have this kind of issues when you run your file. And most of the time, if I don't want to waste my time to debug this kind of thing, I just delete and start over. But you can't just delete and start over, especially when you're in production. So for us to save time, I'm just going to copy this, and then we'll figure it out at the end what the problem is. I'm not importing this. I'm just going to put the code here. And let's see if we create the table first, and then we'll know how to handle our imports. So we still have map int type does not support item assignment. Why are we having all of these errors now? So let's retrace our step. So we have id is equal to map int, and okay, so I know what the problem is here. I don't think we are supposed to use the equal sign there. We're supposed to just write id, and then we use a colon, I think. Yeah, sorry, id colon map int and this. So the equal comes after that. So that's what we're supposed to do here. So take note of these errors. Here too, the same thing. Take note of these errors so that you will understand what is going on when you meet them. So now we're going to run the app file, and now everything is okay. When we go back here and we refresh, we should see the users table, and we have the users table. So let's look at the structure of this table. We have the ID column, which is the primary key. We have the email that we made unique. We have the password, and now we see the role has this enum, admin, client, clinical, like we defined, and the created at is a date time, like we defined. Okay. So now let's look back at why this import for the model did not work. So I'm going to, on the users file, I'm going to delete this and try to import it again. And then I'll stop this, and then I'll run this. And everything is working perfectly. So these things, sometimes you will never be able to understand why the error that happened when it happened. But my suggestion to you is, every time you have a problem like this, just try to click run, or try to look for what works and then go back to retrace your step. So now the import works. Nothing was the problem initially. I don't even know what the problem was, but it works now. Okay? Anybody with question?
No.
Is it understandable? Is it clear?
Yeah.
Okay. So now we've created this users table. So for every table we want to create, we want to write a new file or a new model. We don't want to create everything on the same file. For it will be better for us to maintain and manage that way, instead of having everything on one model's file, and then managing or maintaining becomes an issue later on. So let's look at the other table that we want to do. We want to have a maternity table. And the maternity table, like we discussed in week 14, we want to have a table that holds basic demographic information about the client, just general information. And we say that the maternity table is going to hold like the parent key for all of the pregnancies for a particular person. So for instance, a particular woman can be pregnant today, give birth, 2 years time she's pregnant. We want every pregnancy registration to be linked to the maternity account, so that all of the records of one person is under the same maternity record. So all the pregnancy records are under the same maternity record. So thinking about it this way, it gives us an idea of the structure that we want to build, which means that we want to have a maternity table, and then we want that maternity table to hold the parent column to the pregnancy table, or we want the pregnancy table to hold a child column for the maternity table, so that maybe we have one maternity number, and for every pregnancy the maternity number reflects, so that the pregnancies are all linked to the same maternity account. I don't know if you understand the structure I am imagining. So let's do it like this. When we create it, to understand better, we want to create another model, and we want this model to be named, let's say, maternity. And this model, we want it to hold a table, or maybe two tables, because we want to have, so we can separate information into multiple tables. One information on a form. So we have information on the maternity table that collects name, date of birth, maybe patient number or hospital number. And we want this to be on a table by itself that matches the patient number to the names and the date of birth. Then we want another table that now uses the patient number, has the unique ID, in that new table, let's call it registration information, that now collects things like gender identity, sexual orientation, ethnicity, street address, or all of that, and phone number, email, emergency contacts, and all of that information. This structure, you can decide whatever structure you want. Just make sure you keep your table integrity. So the structure I'm going to choose now is for us to create two tables for the maternity records. One will hold the name and ID, and the other will hold all other registration information. So we want to use the enum also. So let's import enum. We also want to use, import. So because we are going to have information that requires answering yes or no, like we want to take previous medical or medical conditions, and we just want to answer yes or no. We want to have a list of predefined choices also. So let's import something we call options and optional, and we import this from a module called typing. We also want to import date, time, and integer and string, and this time also foreign key, because we talked about having two tables for maternity where one is the parent, one is the child. So we need to have foreign key also. So we say from SQLAlchemy, import, and we're going to be importing date, time, integer, string, func, and foreign key. Okay. We also want to import mapped column and mapped, and because we are dealing with foreign key, we might need relationship or we might not need it, but let's just import, and then whatever we need we import later. So let's say from SQLAlchemy.orm import. I don't want relationship for now. I'm thinking we might not need it, but we might need it. So let's do that, mapped column, and let's do mapped. Okay. So we have all of these imports, and then from models, we're importing base and base model. We said we want to have predefined list of choices for in our table that answers yes, no, not applicable, unknown. We can create a class called choices, and this class is going to, you want it to be an enum. So we want it to say yes is equal to yes, no, not applicable, and then we have unknown, like this. Then we want to have another list. Let's say we want to collect gender identity information. So let's say this gender identity will be a predefined list also. So let's say class gender identity, and then we'll have enum, and we want this to be, let's say, male, and we'll have female, and then we have, let's say, non-binary. Let's just keep it short. Okay, so these are not the standard list of gender identities. We just use this to keep it short. So an example. So when you are following with this and you're developing yours, you try to change your column names, do something different for you to see how much understanding you have. So I said I want to create two tables for the maternity registration. And these two tables, let's say I want to name one client and one registration info. So the clients table will just hold the patient number, the names, and the date of birth. And then the registration info will hold all other maternity registration information. So let me have class client like this. And this will inherit, let's say, base model. And then we have table name clients. We want this to be integer, primary key onto increments. We want to have something we call the patient number. Let's say it's patient num, and we say this is map string and is equal to map column. Let's just give it any length, and the unique is true. We have first name, we have middle name. Let's say we have middle name here, and then let's say we have family name, and then let's say we also have date of birth. Okay, so we have created all of these columns for this table called client. Let's create a new table called registration info. Let's say client reg, and we'll do the same base model, and then we'll say the table name, let's call it client reg, and then we want to, or let's just call it registration info. So we want to give it meaningful name, and then here we'll say we want the ID is equal to map int. We want this to be primary key auto increments true. We want to have the patient number. Now this patient number, we want it to be a foreign key from this patient number here. So we're going to create it like this. So we'll say patient num, and we don't want to, so there's no point for me to put all of this length. I can just make it just map column foreign key without having string 255 like this. So the foreign key we imported, in the parentheses, you specify the name of the table, which is client, dot the name of the column from the table that it is inheriting, or that it is that's the parent table for this. So this is how we basically write foreign keys when we use SQLAlchemy. So put special num, maps, string, and then we just say foreign key, map column, foreign key, and then the name of the parent table. Then we want to put, let's say, gender identity. Now, remember we created a list here of gender identities, so we'll just use this one. So let's say gender identity equal to map gender identity, like that. We want to have another column. You can refer to your forms to just look at the different form fields, the forms in your course resource, but I'll just randomly just use stuff so that we can just see how this is done. Let's have sexual orientation, and sexual orientation will just be a string. Let's have ethnicity. We can also have a predefined for ethnicity if we want. We also have, let's say, the address. Let's put the street address, and we have the city, the state, let's say the zip code, the phone number, and we want to have the email address. So any of the column that is not required, you can make optional, like this middle name here. Maybe not everyone has a middle name, so we'll say mapped, and here you put another and you say optional, like this. Let's use this one as the shortest example we can have. So when you're enforcing if it's going to be a field or a column that must have data, you do it like this. It can be optional if the user must provide a value or not before the value is inserted in database. You'll use the optional like we did here to say it can be empty. So let's do this for middle name and not for family name. So let's say for middle name we want this to be optional. So take note that you can use the optional like that, and you can use it on any of the columns in this one. We'll just make everything here required just for the sake of this example. So let's say we want emergency contact. We want the emergency contact phone and email. Let's say the relationship. Let's have emergency contact address. So let's have preferred language. We want to have something like GP name. We want to have GP phone and GP address and GP email. Let's put just email and stop there. We want to have long-term conditions. So we have, let's make it map string. Let's have medications, allergies. Let's refer to the form. See, okay, so now let's use the one with choices like heart conditions, and we use maps choices because now we'll have the choices for yes, no, not applicable, or no. Okay, let's say diabetes, high blood pressure. Let's have epilepsy, asthma, let's say cancer, mental health, and let's look at substance abuse, drug use, other conditions. Let's look at alcoholism. Let's put family history, and then we want to have stomach. For this, let's just add this. I'm seeing this on the form. Stomach or bowel disease conditions. Let's look at that, and let's just stop here and just do date created. Okay, but this is how you create your model. On the form, you see a lot of stuff. Now we don't want to deal with the front end in this course. We just want to do back end and look at how we can do a functional system. We can create it in functional way. So now we have created all of these columns for this table. We created two tables to hold the maternity information. One we call clients, that will match the name, date of birth, and the patient number, and then the other that will just hold the patient number and link all of this information to the identity of the person. So in this kind of structure, when it comes to encrypting identifiable information, it will be easier because you know what table holds information that are sensitive. Or you can even decide to move the address here, because addresses and or everything that can identify a person, you can put all of that under this table so that you know that what table needs to be encrypted, and the other tables don't hold any information that can identify anybody, and so it makes it easy for you to manage your security later on. Okay, so that's the idea behind doing it this way. So we can just decide once and for all to move all identifiable information here, like all this emergency contact, email, this. We want to move all identifiable information to this table. So when we are doing a real life system, when we're collecting information from a form and we're sending it to the database, we can send it encrypted, or we want this table columns encrypted, whatever structure that you want to use for your security. But the structure I've done now is to have a table of client information that are identifiable information, and then another table that holds information that only has the patient number but does not link to a real person, except if a link is established between both tables. So these are the kind of structures you want to think of when building your system. So now we have this. What is the next thing we have to do is to come to the app file to make sure we can create a table when we run. So we want to import, we've imported the users before, now we want to import maternity. And here we'll say maternity.client, we want to create this, and client read. So we can also just run one code to create all the tables on one file, but we'll just do it individually like this for now, as we are just using this to learn. Okay, so we say we want to create this client and client read. Now recall that we have previously created the users table here, and we see how the columns are. So let's try to run that to see if all is well before we go further, and if not, we debug and then we'll continue. So we'll come to the app file and we click run. So all is well, this file is running. Let's go back to the page here to see if the tables are created. So we have the clients table and we have the registration info table. So let's look at the clients table here, structure. So we have everything that we wanted. The patient number is a unique column. We look at the registration info. Let's look at the structure. We have the same patient number, unique, and when we go down to see, we will see that it is the primary key is the client table. So this is an example. So I want you to create your pregnancy registration and all the other tables. We might do that in week 16 lesson, but now let's go into creating the functions that will process a lot of this stuff in a non-Pythonic way. Let's say we are learning Python, we don't understand how to do things properly. We want to just write the code, make sure it works, and then start rewriting the code step by step to make it neater and okay. So let's do it that way. What I want to do here is to come to my app file, and I want to insert records into this table. We want to be able to use transactions, and this makes it easy for us to use transaction when we use and then also want to use context manager or something that can help us manage these resources. Let's go to the app file now, and what I want us to do on this file is to try to write code that will insert records into some of these tables for us to be able to test if we are having this work properly. Okay, so I will say let me do that here. I'll write it within this create app function, but this is not the best way, but let's just do it this way first. Okay, I will say let's just put a comment here so we'll know what we are doing. So we're going to insert into the let's say insert into the tables. Here I want to say, like I said, handling resources. So I will do with engine.connect has connection. I want to do something so that when we exit this block, automatically the connection closes. So has connection. So I want to do connection.execute. And what are we executing here? The user table is what we want to insert into. So say user.user. Let's get the table name .insert. And what are we inserting? We'll put it in this parentheses. Let's put it here. So we want to put the column. We want to put the column names and the values. The name of the column and the value we want to insert into that column. Okay. So let's say we want to insert into the email column, and what I want to put here is, let's say, let me put my email. I want to insert into the password and the row admin, and I won't insert into date created, because what we did here was to say, let's go back to the user model, was to say created can do the timestamp of now here. So let's try to insert into this without the date created and see what happens. We also want to do another insert, and we want to insert into, let's say, maybe the client table. Let's just do 2 inserts, because this other table has the client, it can be easier. This other client rate has a lot of records to be inserted. Or we can stop here and you can try using the same method, so we can cover a lot of topics. So we can do this, and once this is done, the next thing you want to do is to close or to commit this connection. So let's say connection.commit. Okay, so let's try this and see if any record is inserted into the user table. So let's try that. There is a prefix that I would have added here, but let's make the mistake first before I do that. Mistakes are good for you to learn. So I'm going to leave it like this. We are going to insert this. I think I'm thinking this is wrong. So let's say connection.execute. We want to put it in the users table. Oh no, it's not .insert. This is supposed to be .values. This is where I knew something was off. .values, like this. This should be the correct one. Did we import insert here? So connection.execute here, we're going to insert first. I think that's what we're supposed to do. So connection.execute, we insert, no, this doesn't close here. It closes here. We'll put table and then .values. I think this is the correct syntax. But if it's not correct, when we run, we'll trace our step. So the correct code is connection.execute. Then in the parentheses of the execute method, you put the insert method, and in the parentheses you want to list your table name .values. So this syntax is similar to the MySQL syntax, where we are trying to insert into a table name. We'll put insert into table name, then values, and in parentheses. So that's what this is trying to say. So this is the syntax. I think this should be the correct syntax. And so when we run this, what we want to see happen is to see this record, this email address, the password, the role, and the timestamp of now inserted or in the table. And because this ID column is auto increment, it will start from 1, 2, 3, and so on. So let's run this to make sure all is well. Okay, we have an error here that says, where's the error? On line 26, and duplicate entry for key email. Now let's go back to the table. So I think this is the mistake I wanted us to make. So let's go to client here. Users. We have this is inserted, it is created. We have an error that says duplicate entry. Why do we have the error? When I create or insert into a table, we used to use this in MySQL, insert ignore. But if we want to do this in SQLAlchemy, when we put this, we can say, let's put role is equal to admin like this. You can say dot, and we'll say prefix with ignore, like that. I think this is what we're supposed to do. It's another close parenthesis here. So when you do this, the error we had here will not occur anymore, because we are not going to be having duplicate entry. It will not insert if it already exists. So I'll clear this and let's run again. Now everything is fine. There is no error because we've used this prefix with ignore here. So take note of how to create table if not exist, and to ignore something if it already exists. So we have this here. We don't have errors. So as many times as we run this, we will not have error because we have said prefix with ignore. So it will ignore the creation or the insertion of this record into the table. You can insert multiple. You can keep inserting. Before this close parenthesis here, before the commit, you can insert more. So let's just copy this and insert another one. And let's say this one is test account 24@gmail.com, and we'll leave it like this. When we run, sorry, I'll just end it and run. Everything is well, it seems. And then when I come here and I refresh, I should have 2 records now here. So we can see that we have 2 of them here, the test account and this one that we just added. So we have seen how to do this in basic form. You need to go and explore. I'm going to create a repository and share the link where I'm going to clean up this code and send them, but I want you to try first before I do that. Maybe in the next 2 weeks. I don't want you to just copy this without understanding. I want you to try to do it yourself and get an understanding. Now we've done this thing in a non-Pythonic way, in a way that beginners will actually write their code. And we're not trying to make this complicated initially. You want to write your code, and then you come back and read the code. Don't go far into development before you come back to read your code and see if there are better ways you can optimize this, or you can maybe make it better, more manageable, more maintainable. So which are the better ways that you can do this? We can see that writing this whole thing here is not the best idea. We can actually create a function that can do this, and we can just make this look neater and better. What if we want to insert into maybe want to insert codes into all of these tables that are very long? Do we want to just keep crowding this file up and make it endlessly long? So how do we do this? One thing I can think of now is to create a new file, and let's call it like our helper file, since we are trying to go into functional programming. I will just say here in the root directory, let's just make it simpler. I'll create a file and I'll name this file utils.py. So every utility code, everything I want to do, functions or helper.py, whatever name you want, just make it meaningful for other developers to know what it is that you are trying to achieve on this file. On this file, I want to create a function that will insert data into the database without having to write all of this. So I want to delete this from here, and I want to write a function that does this. So because I want to insert record here, I think I will want to import the insert from SQLAlchemy. So let's say from SQLAlchemy, import insert. So this is the only import I think I need. If we need more, we will do. So I want to create a function called insert data. And in this function, I want it to take, and this will be the best illustration for keyword arguments, I want it to take the engine. If we look at this, let's see. So we want this engine to be an argument. We want all of these values to be keyword arguments. We want this table to be an argument also, or to be a parameter. So by defining it with the engine as a parameter, the name of the table as a parameter, and keyword arguments that will take the values. So that's what we're going to do here. So let's say we'll say the parameters will be engine, and let's put table as parameter name, and let's put keyword args like this, because we don't know in advance how many keyword arguments will be provided. Now you see all of the things that we've been learning are coming into play. So we want to put here now and say with engine.connect as connection, we want to do something. And what we want to do is to say connection.execute. So what are we trying to do? We want to insert. So when we put the insert function here, we will pass the argument table. So we'll say table. Sorry, this is not well correctly spelled. So we'll say table, and we'll use the magic method to get a table name like this, table like this, and dot values, and then we'll provide keyword arguments, because we don't know in advance how many keyword arguments that will be needed. And so we'll just use keyword arguments so that the user can provide the column name and the value, and then we can use dot prefix with ignore here. So we've created a function to make this neater. I hope this function is correct. We'll test it and to see if it's correct. So we have a function called insert data. We're passing the arguments. When we look at this, we see the kind of things we use here. We use the engine, we use the table name, and the values. Now, because we want to insert across different tables, the values will not be the same. The column names are not the same. So we just use keyword arguments. Now recall in one of our lessons when we did functions in detail, we looked at how to write a parameter when we don't know in advance how many keyword arguments the user is going to supply. And this is one of the use cases where that is useful. So we come here and say we use keyword argument for the values, so that when we supply keyword argument, column name and value endlessly or across any table, and this function is going to work across that. And so we'll come back to the app file now, and we can say we don't need this from here up until the commit statement. So let's comment it out. And so what do we do now? So on this, I think we have to commit here. Let's say connection.commit. So this function is done. We want to import that function here. So let's put here and say we're importing from utils, import insert data. So we have imported the sorry. Okay, I just did something here. So we have imported the insert data here. We want to now replace this whole insert operation with the code, with a different code that will just use that. So because we have done this, we'll just call the function insert data. We want the engine. So these are the arguments now. The table name, now we say users.user that we have there, and then the values now are keyword arguments. You can supply endless keyword arguments, anyone you know, because we use keyword args there. So we have email is equal to, let's just use new email so that we can insert them, test@test.com. Then the password, we'll put password, and the role here, let's put clinical or client. Let's insert the second one, and then we'll test. So let's say email is equal to test2@test.com. Let's just use this. Password is equal to password, role is equal to, let's make this clinical. So let's see if all is well now. We've replaced all of these. I'll just delete them. So we just have replaced all of that with just this line of code. So you can see how neater it looks, putting all of this in a function. Now it's more manageable, it's more maintainable like this. Let's come to this app file and let's run this to make sure all is well. And we expect to see test@test.com, test2@test.com has users in the users table. So I'll run this, and module utils not found on line 5. Now we have, okay, sorry, this utils is in the models folder. We need to put it in the root because that's the way I referenced it. So I'll move it and it should be found now. And when I run this, we have this, everything is working fine. Let's go up there, and then I will refresh, go back to my users, and I have them inserted, and with the timestamp of the insert. Okay, so this is how we retrace our steps. There are a lot of things we can retrace on just this example we've done today. We also always want to put our return types like this. There are different ways we can structure this, and like I said, I'm going to have a repository that you can clone of the proper Pythonic way or more professional way of writing this code. If you go straight into professional way of doing it, you won't understand some depth of logic, and you won't understand how to look at your code to be able to retrace your step and make it more optimized, more maintainable, and even better. So every time you look at your code, you can think of better ways and shorter ways to write the same code to work more perfectly. And if you have questions, you can ask now.
Okay. I want to ask a question.
Okay.
Yeah. So while we're developing our own system, we would not need to. So I just want to confirm if the insert process is for just testing purpose and is not part of the build of the system, right? So we only do this for testing purpose.
Yes, you can actually have seed data in your, like if you want to test for test purpose, yes, this is the way you test, because we are not using a front end now. You just want to see if this code will actually work when values are passed from the front end. So all of these are for test purpose. We need to see that test in your final project. Okay, so another way we can do this also is not to do this here. We can have another file here that will say test utils, and then we'll run all the insert query in that test. If it works, we've not gone into testing yet. I don't know if we'll go into it in this course. If we have time, the last week we'll look at how to test our code in a different way. So you can have a new file called test utils that will test all of these functions. Did that answer your question?
Yes.
Any other question? All right, in the absence of question, this is where we end this lesson. So thank you, and see you in the next lesson.
Thank you.
Thank you.
Thank you.